Welcome. Thank you for joining us. Today, we are going to be talking about NanoSTAKE, but it's a little different than some of the other webinars we've done where we tell you all about how great NanoSTAKE is. NanoSTAKE is still great, but we're going to teach you how to use it this time. We're going to go through how the NanoSTAKE process works, how the NanoSTAKE process parameters affect it, and how to adjust those parameters on a machine. And we'll teach you about some common process issues that you might see and how to resolve them. I'm Jason Dornbos. I'm a sales manager at Extol, and presenting with me today, and actually in the same room, which is why they're muted, but you can still hear them because we're actually all in the same room. We have
Catherine Urives. I'm an inside sales engineer at Extol. So if you submit any requests on our website or give us a call, you've probably talked to me before. My background is in our applications lab, so I've had a lot of hands-on experience with NanoSTAKE. And then Jordan next to me.
Yeah, Jordan Schnick. Hi, guys or ladies. I work specifically with the integration team, so selling, supporting, and kind of stuff like this. Whether it's on a webinar or in person, I am very much tied to the NanoSTAKE and InfraSTAKE welding technologies. So
Jordan sees everything.
That's pretty accurate.
Yep. Yep. All right, well, let's get started. Oh, by the way, so we have this meeting chat, and if you can't tell, we're trying to make it as engaging and interactive as possible. So please don't hold your questions. Type your questions into the chat when you think of them, and we will do our best to address those as we go along. We're not going to save them to the end if we can help it. So with that said, quick overview of Extol. We have engineering services, plastic assembly technology, and custom automation. We are going to be talking about NanoSTAKE today. Amongst the other different plastic assembly technologies, NanoSTAKE is one of two proprietary Extol staking technologies, and we're going to learn all about it.
So the goal of this webinar is to teach you how to use NanoSTAKE. So if you're here, you've probably seen the process before, but just in case you want a little bit of a refresher, here's a video of just the NanoSTAKE process. On the left side of the screen, you're going to see kind of a thermal camera view of what's happening in the module. And on the right side of the screen, you're going to see the actual module doing the staking. So the module heated up, there's a tiny little heater in there that rapidly heats the punch cavity. The module comes down, and when it comes in contact with the part, melts that material down, then rapidly cools so that it is cold to the touch. Here's kind of a breakdown of what you just saw in that video. Like I mentioned, there's that little heater in the end of the module. It rapidly heats to a set temperature. It then comes in contact with the boss through conduction, heats that material until it is formed in the punch cavity and reaches a set position. Then a set cool temperature is achieved and the module retracts. So that's the process broken down. Now, if you have run this equipment and seen the process controller, you've probably seen a very similar graph to this in the past on the piece of equipment. But what you're going to see here is the orange line is what the module heater is doing, and then the blue line is what the position is doing during the process. So as the temperature increases, it increases to your set melt temp. Hopefully you can see my little laser pointer on the screen there. So once a set melt temp is achieved, the module will then start coming in contact with the boss and melting the boss. So as that boss height is decreasing, that module is moving down until you reach your set program position that the module is looking to achieve. Once that position is achieved, the module will begin to cool. You can see on the orange line there that the temperature being recorded is starting to cool down until it reaches its desired release temperature, and then the module will retract. So that should follow exactly what you just saw in the video. The module heats up, melts that boss down, sits there for a moment as it cools, then retracts.
So, parameter recommendations, just to kind of start with something that maybe gets overlooked or is not as cut and dry as some of the rest of this information that we're going to cover. You'll see there's only 4 materials on here. These are not the only materials we can weld. However, these are the ones we see the most often and are relatively simple to offer, some of these suggested melt temps, dwell time, your cool temperature, and then perhaps if it's needed, a smart release as well. This is not you have to use it. This is a suggested start point, right? There are other resins and there are very often fillers that are involved with these plastics that could affect what those set points should be.
Mm-hmm. If you have a material that's not on this kind of beginner list, what sort of steps would you recommend taking?
I would recommend going back to the engineering services slide that Jason mentioned at the beginning, using our engineering services or our process development center. We have a lab equipped with all the different welding technologies that you saw on that screen. We can basically take that specific application, review it in CAD or just with the spec sheets. Optimally, if we have resin or a molded part, that would be best. But we can evaluate that and then determine what is the best welding technology. Mm-hmm. Maybe it's not NanoSTAKE, maybe it is. Mm-hmm. If it is, they should be able to offer some better insight as to what those, starting parameters should be. Mm-hmm. So.
And then they can elaborate on maybe some more specific parameter recommendations and then even give you a cycle time estimate because that can be really huge in the beginning stages of a project.
Sure. Yep. So general NanoSTAKE setup. So this is going to be pretty lengthy. As Jason mentioned, if you have any questions at any time, feel free to just chime in and chat. I'll start with what I think is one of the first items, and that's going to be your pneumatic settings. There are essentially 3 things to look for. What's your extend? How much force are we putting on the part? How much force is being used when we retract the module? And then what is the amount of air you can actually push through these? So your cooling air. The punch extend and the retract, I always suggest going lower. There's quite a bit of range that you can see on this table. The lower you go, the stronger the welded stake will be at the end of the process because we're using more heat and less force to actually achieve that result. Retract is a little bit different reasoning. You want to not degrade or break this boss off if there is any sticking, and lower pressure will help achieve that, right? Cooling air, again, this is something that can be played with a little bit. Ultimately, it's going to come down to, do you want to have a longer or faster cycle time? The more air you're able to push through this module, the cooler it's going to cool down. So if it's not 80 PSI, it's just going to take longer to reach that set point. There's also a note in here because this is kind of early during the setup process. This is, when someone's building the equipment, setting everything up. You do not want these modules to be on an angle. They need to be mounted so that when they touch off on the surface, they're perpendicular. In this situation that's shown on the screen here, you'd come down with the module perpendicular to that yellow mating component, right? Not as it's shown in the image. So don't go with the draw of the boss as you might typically do with some other technologies. It will not yield very good results.
What do you mean by that? Like the look of it might be a little funky, or
Sure.
we just start breaking things?
Yeah, so the module itself is relatively small, and it's purposely designed with a very not a very thin sidewall, but a relatively thin sidewall, so that it dissipates the heat or doesn't absorb all that energy. It also allows us to cool, heat and cool every cycle, so that it's very repeatable. So along with that design, it's more likely that if you were to hit it on angle like this, it could bend the tube. It also could result in some deflection, which is not a very repeatable process in the long run, right? So you could see the module moves or slides when it actually touches off on that surface. That's going to affect your strength. It's going to affect the appearance. It's just overall not going to be a best practice situation. So for those of you who have seen NanoSTAKE, this screen here is going to be very familiar. This is your home screen. This is going to give you a quick snapshot of what the process settings are for each individual module. Let me just grab this really quick. So if you look here, this left side of the screen, kind of where I'm floating around at, this is going to be your process parameters. This is not where you change it, but this is where you can view and see what is actually selected and then how is it performing based off that explanation that Catherine gave about, your module's temperature and your module's position. You can select the modules right here and it will show a graph that's specific to that location. You can also see which recipe is selected and switch through those. In the case where you're doing multiple parts, this might be, more specific to your application. Sometimes you might only have one and it's not something you need to pay attention to at all. On the right side of the screen here, it does show you a little bit of information at the bottom, but this is where you'll go to select your quality parameters and adjust those. This will not control the process. This is just going to give you feedback about what's happening, and then you can set your upper and lower limits for what's acceptable. Basically, this is going to allow you to ensure your process is repeatable cycle after cycle. You have some other buttons down here and then a little dialog box down here. This is going to show, what's going on, whether a fault occurs or if everything's running correctly. This is your home button here. Your setup, this is something that will be done. I don't know if we've got any integrators on the line or if it's mostly end users. But this is generally going to be something you do when you first open this up along with that pneumatic section. This is just going to select which modules are running and which ones aren't.
Okay, so it's more of like a tool setup, not the process.
Correct.
Mm-hmm.
Yeah.
Okay.
So we won't touch on that one too much, but if you do have any questions, feel free to chime in. Moving a little bit to the right, your reset button. If you remember just a moment ago, if we do happen to get a fault, you'll see this. It'll pop up with a dialog box as well. But this is where you would reset it from the system controller. You can also have a bit in your PLC to send that signal to the screen, but it's there just in case that wasn't set up. And then again, another way to access which recipe and also show which one's selected right here. This guy right here gets overlooked quite often, but it is kind of just really quick, important to talk about. This is going to lock or unlock, or rather show what the status is of you being able to influence process parameters, quality parameters, anything on our NanoSTAKE system. This is something that's sent from the PLC, so you can have whatever safety checks you want in place to unlock it. You can still navigate every screen when it's locked. You just cannot affect any of these actual settings without it having that unlocked. So if you go in to make any changes or adjust the parameters, you need to make sure that this guy right here shows like this image unlocked.
So if it's locked, the way they unlock it through their machine PLC.
Correct. It's an input that we have to receive to the NanoSTAKE system. So I'd like to start with this one just because this is something you'll do at the end. So once you're done doing everything, but it's also relatively short in comparison to the rest of this process. I think it's a little more straightforward as well. So this is your quality parameter screen for position. You'll notice at the top of the screen, you've got modules. Every module has its own sensors, whether it's for position or temperature. Time, obviously, that one's pretty easy. Can't see the PDF.
Which guy a positive number is in this moment? I don't.
Maybe what slide we're on at the moment?
We are on slide number 9. Is that helpful?
Is it not moving?
It's moving on my
moving
side.
Screen, so maybe it's just a little bit behind or a poor connection.
Okay. I'll get back to it if, hopefully it catches up, but if not, we are on slide 9.
Yep, and then the recording will follow the slide
at the
pattern.
end,
So,
yeah.
so if you need to go back and watch the recording, we're happy to follow up with you on any questions.
Perfect. So, going back into the spiel about the quality parameters, each module has its own sensors. You can select that through this guy. You get to this point by going through that means I'm going to go back to slide 8. You get to that screen by going anywhere in here. If you click on the position, it will bring you to the position tab. Same goes for the time and the temperature. But once you're there, you can alternate between these guys by clicking that tab at the top. Each one of these screens is going to have upper and lower limits. It's just what is acceptable for your equipment, right? Chances are your screen's not going to look like quite this sporadic. Hopefully not anyways, because that's a pretty large variation.
A lot of
Big
variation.
window.
Plastics all over the place.
Yeah. That in this actually might indicate that, hey, there's a bit of an issue going on, right?
Yeah.
Or you're running a lab setup and you just run a bunch of different parts. Generally, though, you'll see a pretty consistent line going across these graphs, and you can use that to create your upper and lower limits. Or if you've got a quality department that dictates what's acceptable, maybe it's 0.5 mil, maybe it's 1 mil, whatever that range is, you can easily set it here with your upper and lower limits. When you are happy with what you've set, simply hit apply, and you're good to go.
And you just tap on the upper limit, up, down to change it.
Yep. So, plus, minus, whatever you need to do to adjust. You will notice, too, it's not really easy to illustrate here, but this graph will scale based off how tight those get.
Okay.
So like when you start, it's going to be hard to see where that point lies specifically on this guy. But as you move them closer, it actually scales that graph. So it's a little bit more friendly to actually see where that point lied.
So if a part is out of, say, positional tolerancing, it shows up as an error in that dialog box then, correct?
Correct. So if for example, any one of these points, so these were all previous cycles. So this was the furthest, this was the last cycle. If any of these fall outside of this gray box or these upper and lower limits, it will throw a fault and it will say specifically which module it was and what actually was it. So was it a boss position, so pre-weld, or was it a final position? Did we not hit the height that you told it to, or did we go too far? All that will have its own specific error message. And we don't talk about it too much in this presentation, but you will also have an LED on the modules that will actually flash. So if there's one troublemaker, let's say, it'll be pretty quick and easy to understand, all right, it's all well and good. Module number 3 was the one that faulted, but where's it at on the machine? That LED is going to help you assist a little bit in that.
Everybody doing good so far? Any questions so far? Just type them in if you have one. So,
setting the position. There are a few different ways to go about this. But I like to start with actually a good part that has not been welded. You'll see we're actually in the process screen now. So I'm gonna swap back just a little bit to help you guys out, hopefully. So again, from the main screen, right? We went to the quality for that first slide that we just reviewed. Now we're actually looking at the process. This is where you're going to affect how the NanoSTAKE runs, what it's going to run to, and basically all these set points here. This is where you're going to affect it. Again, just like this screen, you can touch off anywhere inside this box, and it's going to bring you to this screen right here. Now, because we're talking about setting the position, go right here. And for some reason, my animations aren't
because your
working.
laser pointer's on.
Ah, okay. That might help.
Okay.
Perfect. Thank you.
Now if you click the, there you go.
So thank you.
Okay.
So if you're in this screen, which is where you will always end up, you'll hit this position tab here. Once you're on this screen, this is gonna make a lot more sense, and this is actually where we're going to be able to teach, again, each individual module. Each one has its own sensor. Each one's going to need to go through this process. So as I mentioned, there's a couple different ways to go about it. The one I like best, what I always suggest to anyone at any stage really, is to take a known good part, load it into your nest, bring your platen with all the modules into work position, and then hit this teach button. Mm-hmm. This is your, easiest method basically to find, all right, what's the maximum depth I can hit on this mating component without, overdriving or going to a unstaked height or not complete stake height. Now it's not shown here, but what I recommend doing after the teach button is adjusting it very slightly. So keep in mind, right, we've removed the plastic boss or the tab, whatever we're welding. And so there's no longer any sort of material that's potentially offsetting it from that surface. I recommend doing 0.3 of a millimeter. So hitting this little plus right here, up 0.3 is a good place to start. What's nice is you don't need to make any mechanical adjustments at this point. This is just where you're going to start at, right? You're going to go in and say something's off the rails, or you're just setting this up now. You're going to set this up and then go through every module. We'll go through the actual process parameters, run a part, and then you can go back here and adjust it. If it's not welded deep enough, you simply go lower, hitting the minus button. If it looks like it's holding up, and we'll get into that a little bit later, you can raise it a little bit. Is it driving into the mating component, whatever it might be. There is also, so since we're on this page and it's a good time to talk about it, there is an option to use time. I always recommend going with position, but there are some instances or some customers who would prefer to use stake by time. This one's pretty straightforward and simple. Say you've used position for quite a while. You've seen in your quality parameters how long it takes to melt the bosses. You could go in here, click time. So go back to your process screen and then adjust what your dwell time is. That is how long it's going to heat up. Without going into the weeds about it, essentially it's going to hit position as soon as it starts, and then it's going to dwell for however long you tell it to, and then begin the cooling process. We're kind of skipping a step right from the start if you use time. But again, position, load a part, snip the bosses off, bring it into work position, teach, and then add a couple tenths of a millimeter to, kind of offset it for that plastic that will be present when you weld.
And always click apply.
Always click.
Yes, good point. I do believe it. Look at that.
It's like somebody thought that
someone went through it. Yep. Yes. So if you do make any changes on any one of these screens, the only way to make sure it actually is taken into account is to hit the apply button. It's something that gets overlooked. It used to be something that was set up to be automatic. The only problem is if you fat thumb something or if you hit it incorrectly, it could throw off your process and you're left wondering why. So. So next part of this is setting up the process parameters. How hot does the module need to get to melt this? How long do we want to dwell or hold that energy once we hit the position? And then what's a good cool or release temp? And then last but not least, and probably this is kind of an iffy if it's actually needed or not, smart release. So we went over that table at the beginning of this and had some suggested melt temps, dwell and cool, and perhaps smart release if it's needed. The melt temp, this one's generally pretty easy to determine, in my opinion. This is going to be dependent on the material, right? I'd say the bulk majority of these are going to be set somewhere between 450 to 600 Fahrenheit. If it starts to go lower or higher, I'd be curious to know what the plastic is. Of course, there are some outliers, but for the most part, if you're starting with 500, it'll probably weld it. You might see that it's going to take longer, or it's going to be a little too fast. Maybe it's burning some of the plastic. There are several things in here that will kind of go over some hypotheticals, but this one pretty consistently, I'd say, is going to fall 450 to 600. And again, if you've got questions, send it to us. Let's talk about it. Let's review it with the lab. Now, dwell position. This one is going to be, it's going to vary somewhat. The out of the box set point is 1 second. What this dwell time does is it allows more of the plastic boss that's above the surface to melt and create a greater cross-sectional area. This is specifically there to basically improve your strength. It will also increase your cycle time. So if that's something that you're more, pushing towards, this might be something that you can save a little bit of time on. Go to a half second, something like that.
Turn it all the way off.
Or you can turn it down all the way to 0. I recommend if you've got the cycle time allowable, keep it at 1 second. Perhaps if you're not getting strong enough results, maybe turn it up to 2 seconds.
It's essentially allowing the heat to soak into the plastic and soften it more.
Right.
Kind of circulate in the cavity a bit more.
Well, not even in the cavity. So we're melting everything that touches the cavity. It's the material that doesn't touch the NanoSTAKE that we're looking to weld with the dwell time. It allows that plastic to basically soak it in. So this one can vary a little bit, but this is something, I'd say for the purpose of setting it up the first time and, just creating a good baseline, keep it at 1 second. And then if you get into some of those hypothetical situations, maybe look at this as a way to aid the process, whether it's to get more cycle time out of it or to increase strength. This might be something to help with that. Cool temp. This one, again, not a huge amount of variation. This one can help with a few other things, though. So set point right out of the box is 150 Fahrenheit. I see this go as low as 100 in some applications. Generally, though, 100 to 150, maybe at 120, is a pretty good sweet spot. And just like the dwell, I'd say run it at 150 and then evaluate it, right? Is it cooling down quick enough? Is it sticking? What's it look like? It's kind of one of those things where you're not going to see or need to make many adjustments to this unless there's a, specific issue that's arising from it.
Why wouldn't you set the cool time to 70 degrees?
So we're using shop air. There's no, AC units or anything that's running the air on this. So if you're working in a shop and it's 90 degrees out during the day or 100 degrees, you're never going to hit that. And it will air out over time, either through your quality parameters or there are preset values in the controller that will basically say, like, it's tried long enough. Obviously, there's something going on. It will allow you to set it quite low. But if you look actually on this screen right here, you can see the current temperature right now is 70 Fahrenheit. That's baseline. That's just sitting there without any heat having been applied.
Right. It's not touching that warm plastic anymore.
Yeah. So this is that's as low as it's in theory going to go.
And once it releases off the plastic part, it keeps cooling the module down to that ambient temperature.
Yes, it will. So yeah, that's a good point to bring up. And that actually, I'm going to scroll back because I like to go back and forth just to make it very clear. So what Jason's talking about is if you look at this guy right here, this is where we began cooling. And if you look, this is where we're retracting the module. But this slope keeps going down. Your temperature is going to continue to go down because even though we've completed the cycle, your platinum's moving up, the module wants to get back to that steady state, whatever it was prior to running, right? That way, when you introduce the next part, your heat time, the actual melt profile, everything's going to be the same cycle to cycle. Very repeatable, right?
Yep.
We heat up, we cool down, we start at the same point every time.
Makes sense.
So the smart release, this is kind of a feature that we added later in the NanoSTAKE process, and this was specifically added to combat some sticky materials. Applications where, it doesn't matter how low you set your cool temp or what your melt temp was, they just have a sticky nature. They want to kind of hold on to that hot tool even after it's cool. What this is going to do is use that low pressure I was talking about to retract just the module. So your tool plate's going to stay here and the module is just going to pull up a little bit with low pressure. Simultaneously, it's going to heat up. And one thing that I see get asked a lot is we didn't hit 500 degrees. That's not a bad thing. It means it's probably doing its job. It's releasing before it needs to hit that temperature. So you can set this where you'd like, but that's where it's going to stop applying heat. And again, just like the cool temp or the melt temp, it will run the smart release for I think about 10 seconds. If at that point it has not sensed movement retracting the module, it will fault out and tell you, hey, this was an issue, and it might be time to go reevaluate that, make sure, is the pressure actually too low? Do we need to adjust any of these other parameters, things like that?
Can you explain a little bit about what smart release is doing in the overall cycle picture?
Yeah, we don't have a image of it in the presentation, but we can use this guy right here to kind of walk it through. So essentially what's going to happen is very similar to this, but much shorter, right? You're going to watch this module heat back up. So it's going to start at 150 in theory, or right around there. So you're starting here. It's going to ramp up heat, and simultaneously it's going to be looking to retract or pull the module off. Once the module senses, I think the target's 1 millimeter on the analog sensor, it's looking for some sort of movement. Once it hits that, you're going to see this guy continue to go back down. Cooling air is going to start right away, and it's going to try to bring it back down to that baseline.
The goal of it is with those materials that don't like touching hot things, after they're cooled down, it creates a little skin in between the boss and the heated punch so that the module can retract. Creates a little bit of a melted material barrier. Is that how you would describe it?
Yeah, sometimes. What I see happen more often than not is if something's misaligned or if the mold doesn't, perfectly match the CAD, you get a little bit of flash somewhere. More often than not, I see the flash actually wraps around the forming tool, the NanoSTAKE, and when you cool it down, what happens when things cool? They shrink. They kind of bites on the tip. So if you heat it back up and apply a little bit of pressure to retract it, generally it helps remove that. The film thing is definitely, if you have an application that's been sticking, you might see some material buildup over time or a fogginess appearance. But more often than not, it's usually some sort of flash, whether it's an alignment issue or a mold issue. Flash is probably the biggest culprit, I would say. So, processing the melt temperature, things to look out for. So, long cycle times, perhaps too fast of a cycle time, material sticking to the punch like we were just talking about, and low stake strength. There is a lot to unpack here, but does anyone have any examples or issues that they've seen with equipment they have, or any testing you've done?
Any issues where it seems like melt temperature might be off? You're wondering if you put in the correct melt temperature in the process to begin with. Have you seen these issues like low stake strength and you're wondering what factors might contribute to that? Anything like that? What I'm hearing is every piece of equipment is running flawlessly. It's perfect.
I was hoping there was one so we could kind of walk through it, but if not, I can kind of touch a little bit on each one. So I guess we'll start at the top, and if someone's typing right now, or if you do have a question, I will stop and we can take a look at that. So a long cycle time. This could be a melt temp. This could also be a position issue. If you're using too low of a melt temp, it could extend that cycle time because it's requiring more force to actually melt the plastic and less of that temp. So you could simply look at adjusting this, right? You could turn up the melt temp, evaluate again after the cycle. How did it run? Is it sticking? Did it, improve your cycle time, or did it not make any difference whatsoever? If you increase the temperature and you didn't do anything else and it didn't improve your cycle time, it would lead you to the idea that, hey, maybe my position is too low, maybe I'm overdriving. And there's other ways to verify that, simply looking at the finished product, but that's the one I would say I see the most often.
Ricardo has an application where the stake gets stuck constantly.
So cleaning the modules is definitely a bit of a difficult scenario, only because you don't want to damage these guys. So you don't want to just grab a pair of a multi-tool out of your pocket and start turning on this guy, or anything that's abrasive for that matter. We have a cleaning kit. It requires a little bit of elbow grease because, again, you're using something that's not abrasive and something that's not necessarily going to be super hard. But it is a, what's the specific material? It's basically like a mold cleaner.
Called Award Glow?
Yeah.
Polish?
No, that's for the that's for the infrastructure.
Oh, sorry.
No.
See my cleaning supplies up.
Yeah. So this one's not going to polish it or anything like that. It's going to help kind of break down, like that film you were talking about. It's going to help kind of remove that from the surface. Ricardo, what I would recommend is basically sending us an image. We can take a quick look at it and then see, is it something that's potentially damaged at this point? I don't know what you've done to try and clean it in the past, but we have a cleaning kit. It's going to require a little bit of elbow grease. What it is, or consists of rather, is a wooden Q-tip and that mold cleaner that I mentioned, and basically just kind of buffing it and cleaning it off to remove that plastic. There's some alternative methods where you can try to melt like a Poly Pro in that situation. Chances are you probably don't have the same molded part that fits in the fixture and you can run through, but Poly Pro does a very good job adhering to a lot of those plastics chemically, right? Bonding, and then you can remove it and it would kind of pull any plastic that's built inside. I would think too, if you're running into a consistent sticking issue, we probably would like to have a chat and see, all right, what are your process parameters? Are you using smart release? Thank you, Jason. Perfect. and just kind of evaluating it and see if we can get rid of the sticking, because even without that PolyPro suggestion, it might be if you change some of these settings, and if it's in the cavity specifically, by adjusting those parameters, you might be able to basically, you might scrap the one part, but you could perhaps adhere it to that plastic,
Get it off. Yeah.
pull it out, and then be good to go in the future.
Oh, well, if only there was a slide in the future on how to set up smart release. So this
Well,
is perfect.
and I will say, for everyone on the line, smart release was something that was added, right? So it is possible that your equipment's running an older version of the software. If it's not showing on the screen, it might require a little bit of work on the equipment, both on the controls side and also on the machine. So you might need another valve, certainly going to need some regulators and things like that. But as far as the software version goes, it is a very quick and easy to do process. We can even send stuff so that you can do it in person there without us being present. Or we can set up something with our service team to make a trip out there and help you guys through the whole process. So
Cool.
So, low stake strength. This kind of goes back to the conversation on dwell time, right? It is also somewhat tied to what your melt temp and your cool temp are. The first thing I like to do personally is look at increasing the dwell time. It's going to extend your cycle time, but it's going to help a lot with that stake strength. Alternatively, melt temp. If the melt temp is way too high, you're burning the plastic, you're degrading the plastic, and it's going to burn off and basically break down. That could be one aspect. So nylon covers in modules. It actually looks like a pretty decent tool.
In case anyone didn't see Blake's message in the chat, he said that this is something that I use and sent a picture of a tool. So it's a 3D printed nylon that covers the head and jaws to carefully clean the module off. So
yeah, I see no issue with that. The plastic itself isn't going to damage the tube. I mean, you could potentially bend something, so maybe just be careful with that. But if you're, kind of just twisting it around or whatever, because it goes back to that flash thing. Most of the material I'd say I see sticking to the module is on the outside. Sometimes you see it in the cavity, but most of it's on the outside edge. So, thank you, Blake. Low stake strength, going back. So melt temp, if it's too high, that might be breaking down the material. And then cool temp. This one's probably going to be a little bit easier to observe if it is the issue. If you're ripping heads off, or if you're kind of cracking or breaking even a little bit of the plastic off, chances are this needs to be turned down, or we need to look at adding smart release. So, a couple example videos of NanoSTAKE with and without smart release.
this is
Low temp and high temp. I'm sorry.
the one on the right has the higher temperature and it reached its position much faster. However, the cooling time is a little bit longer.
Right.
So if you're having that really long cycle time, like you had mentioned, it might be a dwell position thing, or maybe you just want to try bumping up your melt temp. That's probably a
or alternatively, as you mentioned, the cool temp, right? So it's going to melt faster at a higher temperature. It's also going to cool down at a higher cool temperature.
If you want to play that video again, between these two cycles, they are the same dwell time and they're the same cool temperature. The only thing that's different between them is the one on the left is at more like 500 degrees. The one on the right is more at like 650. So just to show you that you can shave a little bit of time off your cycle just by changing the heat temp alone.
So processing the dwell position. So this guy, we talked about this a little bit in length, but as I mentioned earlier, this is something you might go back through after you've run the process a few times and you've already set it up initially. You might want to change things based off the results you're seeing, whether it wasn't staked all the way or if it's driving too far down. Maybe it's creating that scenario where it's just taking too long. And this is stuff that like I said, you're going to find out after you've done the initial setup. As I mentioned in the first slide when we were talking about this too, there's no mechanical adjustments you need to make at this point. It's just a matter of getting to the screen. So from your home screen, hitting your process window, and then going to your position. The longer that the module runs, or sorry, let me back up. The longer it takes to get to that position, the longer the overall cycle is going to be for all of the modules. So if, for example, on that home screen, which I just want to scroll back really quick to because it wasn't as pertinent at the moment, I think now it makes a little more sense. On your home screen, you'll see there is form time, 5.3 to 7.3 seconds. Which modules are these, right? Why is module 1 5.3? Why is module 3 7.3? This might be one of those scenarios where you want to adjust your dwell position. Perhaps it looks like, yeah, all right, 3 is driving into the mating component a little bit, or it looks like it's kind of tapering off for a long time, kind of like you can see in this image right here. So like it's coming down and that's flattening out, right?
Like it's stuck.
Right. And it's probably too low.
Mm-hmm.
And so to adjust that, you're not going to hit teach again, but you'll go in here, hit the plus, whether it's a tenth or a couple tenths. You can actually use this graph to observe and see, all right, what's the point at which it actually starts to net out? And then, move it up to where it's got a little bit of movement, run the cycle, and evaluate what's it look like. Does it look like it's good? Does it look like it needs to go a little bit further? And then go through this screen, adjust it plus or minus. Just make sure when you do this, you are on the right module. At the top here, it's the one that's highlighted. You could go into this and you're wanting to fix number 3, but if you're still on number 1, you're not doing anything to fix the issue. Perhaps you're making it worse, right? So you can start chasing
that problem before or something.
Yeah, you can start chasing your tail pretty quickly.
So pay attention to the module that you're adjusting.
And always hit apply.
Yes. Video time, isn't it?
Yeah.
Yes.
So,
I'm very proud of these videos.
So this video, if you want to push play on that, is just a normal cycle, but your dwell position is set too high. That kind of sign that Jordan was talking about, where take a look at your stake after it's completed. What do you see? This one is not fully filled. You can see that there's a gap between the dome of the stake head and the mating component. And if you were to get a true side view, which is really difficult to get a picture of, you'd see that mating component can float a little bit.
Yeah, there's actually a shadow underneath that washer.
Yeah.
It's not tight.
This guy right here, right?
Yep.
Well, and even
then
down
even
on
lower.
the plaque.
Oh, yeah.
Mm-hmm.
So that's a case where your dwell position set too high. Your cycle time was probably pretty quick because you weren't melting all the material that was supposed to be there.
Yeah, and that's going to, and in some cases that might be acceptable. It's really up to you guys to determine if this is good or not. I would say 9 times out of 10, it's not.
Mm-hmm.
This will also affect the overall strength, right?
Yeah.
You're not melting all the material that's present. It's going to have a weak spot.
Mm-hmm. So this video is your dwell position is set too low. That module is trying to reach a position that is too low. It can't get to it because that mating component is keeping it from reaching the position you set. So it just sits there.
Yeah,
and sits there and sits there.
And so going back to the quality parameters, if you're concerned about this happening, 2 things. You can set how long is acceptable for these to heat up.
Mm-hmm.
Again, lower, upper limit window for that. But besides that, there is also built into the controller a timeout for how long these will heat.
Mhm.
And it's calculated based off what your actual melt temp is. So that's going to scale. Like if you're up to 800 degrees, it's only going to heat for, X amount of seconds. If it's set at 500, it might, heat up for 40 seconds, but it'll scale based off what that is. Just so you're not, melting through an entire part or damaging a module or anything like that. I think the end result with this type of application or this type of setting is pretty easy to understand based off the image you guys are seeing, but it's not always going to rip that off.
Mhm.
More than likely, in most situations, you're just going to see a lot of flash or the module buried into the mating component. Like if it's plastic to plastic, you'll see this module kind of just bury into the actual part.
Which is bad.
Which is bad. That will create more sticking.
Yep.
And maybe we'll
Smart
ruin your
release.
module.
Smart release will not solve that issue.
Yeah.
And then this last one, everything's set up so well. The dwell position is set correctly. Just wait to see how beautiful this stake is. Maybe I'm a little biased because I set up the process, but oh, it's so beautiful. It brings tears to my eyes.
Yeah, so this one is easier to compare against the first one, but yeah, like Catherine said, this is a very clean stake, right?
Thank you.
You can see there's a very slight imprint on this surface, basically just ensuring that you've completely netted out, you've completely filled that cavity, and there's no gaps or anything like that. There's no shadows. Everything here is nice and tight. This is your best scenario, right?
Mm-hmm.
Say you're there. You're happy with the results you have. Everything looks good. You've gone through the dwell position. You've gone through the mag setup. You've gone through setting all your melt and your cool. And you're good, right? Want to set it and forget it and let it run. One last thing that I think needs to be looked at when you get to that point is the hard stop limit. This is something that does not get used very often, and I think it's just overlooked because when your machine builder is typically putting this stuff together, there's a lot more that goes, running through this, and there's going to be tweaks and things like that. This is the last thing you want to do when you're setting up the process. Even if you need to go back and change something, maybe open this up. This is going to prohibit this module from traveling further. So earlier I said you can make all these changes through the screen and not need to mechanically adjust anything. If you want to lower the depth or the position that it drives down to, and this is too high, that could stop you. And it could also create that, hey, dwell position too low scenario where the module just continuously heats up and can't hit its position. It is possible. I'm just going to go to a position screen really quick to use this as an example. It is possible to see what the current position is of your module. So when these are sitting at the top of the tool plate, you can go on here, and if they're extended right, or maybe you manually fire them, you can go through and check every module and understand, all right, how far can this module actually travel?
Mm-hmm.
You need to make sure that this current position is always lower than your dwell position when there's not a part present anyways. Because if this is higher, say this was 2.8, you have a physical hard stop that's preventing you from hitting 2.7.
So the purpose of the hard stop is to keep the module, it's not to control the process, it's to keep it from going too far.
Correct. Yeah. It's to stop you from ruining your main component. We do a lot of, PCB applications, sensitive components or anything like that. You don't want to sink heat into that part. Maybe you just don't want to tear up whatever the plastic part is and bury it and then, run into sticking issues or damaging modules. The hard stop is there simply to stop module from traveling, right? And I think most people that are dealing with any sort of equipment are familiar with a hard stop. So this same idea, same purpose, very easy to set. And generally what I would recommend is, I'm going to go back to that screen just because actually, you know what? There's one that's a little bit bigger. Let's go with this guy. So what I would recommend is When there's no parts loaded, you're happy with the results, everything looks good, I recommend going back to this position screen, manually fire the NanoSTAKEs or make sure they're extended, right, and fully netted out. What is your current position? And then just bringing that up so that it's slightly lower than whatever your dwell position that you've taught it is. Mm-hmm. So in this case, I'd say, run it up to 2.4, 2.5. You can still hit 2.7, but you're not going to be able to travel much farther. Mm-hmm. You're not going to be able to sink a bunch of heat into that component. You're not going to be able to drive through it and damage it. And you can do that as a one person, right? If you have like a light curtain or something like that depressurizes the system, perhaps you hold it down with one finger while you take a wrench and adjust that nut. But it's not overly complex. It's meant to be pretty simple, hopefully. And again, as with everything else, if you need help, give us a call. So
cool. Okay, we got 4 minutes left.
Oh man. All right. I will talk about this really quickly then. So processing smart release. Basically, like I said, this is a last ditch effort in a way. If you haven't been able to process out with your melt or your cool, the sticking and stringing, or maybe position if you're overdriving, smart release is going to help assist the sticky situation that you're in. Some materials are more likely to stick. Your nylons, your PBTs, it's just the nature of the plastic. This is something I would look to add last. I would say if you can, send it to us. Let's have a chat. Let's maybe run some parts in our PDC. Chances are, I would say not as much as 9 out of 10, but 8 out of 10, we can find a good process here without using smart release. Mm-hmm. Smart release will increase your cycle time. We don't want to use it unless we absolutely have to, but it is there in the situations where it's needed. If it loads. Sorry, guys. All right. So smart release off on the left side, smart release on the right. You'll notice that it's going to take a couple more seconds on the right side once these modules reach position, but the module retracts, whereas without, it pulled the entire part out. There's no clamping tools or anything on this, so it'll pick up the whole thing. This can damage the modules. This will obviously not have great results for your part and create some headaches where you start to get plastic building up on your equipment. So we're running a little bit low on time, but some common troubleshooting issues. We're ripping off the modules. Let's look at what your process parameters are. Do you need smart release? If your module won't retract, check the pressure. Check to make sure it's not sticking to the plastic. Again, do we need to adjust parameters or do we need to use smart release? Cycle failing, screen says melt overtime. Also, just a really quick interject on my own, real quick rant. All this stuff is in the user manual. There is a troubleshooting guide that says, if this is the fault you're seeing, this is what we'd recommend you do. Mm-hmm. So even if you can't get me or Catherine, Jason, or someone from the team on the phone right away or in an email, look at the user manual, download it from the website. It's going to have scenarios. If I see this, then I should do this. Mm-hmm. And it'll have a couple things to troubleshoot and look through. So that all said, you're getting melt over time. Chances are position's too low. Maybe the melt temp's not high enough. Cycle failed and the screen says heater over power or temperature sensor out of range. This one, in my experience, is something has happened to your module, whether there was a crash or if there was something that happened over time. It might be time to replace that module, unfortunately, but that's one that I've seen a fair amount in some, not the greatest setups. Typically, there is a root cause as to why it happened, but definitely needs to be evaluated more. Module vents are covered in plastic. Unfortunately, this happens a fair amount as well. This is part of why the hard stop is there. It stops you from driving into this. If your module vents are covered in plastic, plastic is inside the module now, and it should be replaced. This is going to affect some of those sensing capabilities that we have, so we're not going to be able to hit temp. You might see heater over power or temperature sensor out of range because plastic's gotten in there, and now it's messing with those conductive pieces of equipment. And then, yeah, last but not least, what have you seen on your machine with a few minutes left?
Yeah, if you've got any issues that you've seen pop up on your machine, seems we're out of time, feel free to either drop it in the chat and we can follow up with you, or Jason's going to get the recording sent out and that manual that has that troubleshooting guide in it. So if you want to just reply to that email, we'd be happy to get you in contact with Jordan, our service team, or our other staking specialist, Casey, whoever can best fit your needs. So if you've got to jump off because we've reached our time, that is totally fine. If you've got a couple extra seconds and just don't know who Extol is, we just wanted to take a minute and explain who we are. Maybe you worked with an integrator and haven't worked with us directly. Thanks for using our technology. We hope that you love it and that this is a good guide for you in what the technology does and how to use it. But Extol as a company, our goal is to solve your difficult plastic manufacturing challenges. As I'm sure you could tell from this presentation, we've got deep technical expertise in both the equipment and the technology side. So we like to try and kind of merge those two ideas together. In the industry, you get people who are plastic welding experts, and you get people who have custom automation expertise. Plastic welding providers don't always know the full depth of how to execute custom solutions, whereas custom machine builders don't necessarily have that deep technical knowledge in plastic joining. They can make a machine doing anything under the sun, but the specific expertise as to how the technologies work maybe isn't necessarily their specific strong suit. So where Extol comes in is we want to be the best of both worlds. We want to provide you with that configurable plastic solution that is optimized for performance for your specific application. Like Jordan said, maybe it's not NanoSTAKE, maybe it's InfraSTAKE. We can advise you on that. You don't have to make that decision alone. We can help you with that prototyping or any other sort of validation testing to ensure that you are getting the right technology and the right solution. If you have a preferred machine builder, we can work with them to get that technology up and running and specifically successful for your application, or we'd be happy to do any sort of standalone, fully automated or semi-automated equipment in-house. So that's a quick little spiel about Extol. I don't know if either of you had anything else you wanted to say before everybody hops off for lunch.
If this training is something that you would like to have your team trained on in person, drop that in the chat. Say, hey, I want you guys to come in and train our team on the NanoSTAKE machines that we have on our floor. We can do that. And so put that in the chat. Say, hey, that's me. I want help. Yeah. Because it's a webinar, we had to, and we try to do some troubleshooting things, but talking about your specific machine and your specific application, I know can be even more helpful for some people. So let us know. There's
a lot that we can cover on the screen. There's even more that we can do in front of the equipment. And it's going to be a lot better to follow and get an understanding for yourself so that you can go through the process of troubleshooting things or just setting up, getting a general knowledge when you can actually hit the buttons and make an effect to the part, and then everything just clicks, right? It's gonna tie together a lot better if you have the equipment in front of you and you can actually play with it.
We've got a demo kit for the NanoSTAKE technology. So if you don't have a machine yet, but you're going to, or you want to have the technology, don't worry, you can use our demo kit. We can do it on your machine. We can come to you on your floor. You can come to us and use our demo kit. We can come to you with the demo kit. We've got options, to say the least. So don't let logistics stop you from being knowledgeable and confident with the technology.
Yeah. Great. Well, thank you everybody for joining, and I hope you all have a great rest of your week.